All right, Bobby, I'm going to make this video strictly for you. Okay, so it looks like you're running a repeated measures ANOVA with two repeated measures. I've never seen that before, but I don't see why we can't do it. And I'm going to answer all your questions along the way. Okay, so here we go. So here's our first repeated measure is empathy with four repeated measures, right? B stands for baseline. And then after 3 months, after 6 months, after 12 months. And the next one is performance. B is baseline. It's pre anything. And then 3 months later, 6 months later, 12 months later. First thing is you got to look for normality. Okay, so for normality, we're going to go to Analyze, Descriptives, Explore. And we're just going to stick them all in there because that's an assumption for all your DBs is the data has to be normal. And we're simply going to look at the mathematical parts. Well, we could do the histograms, I guess. But this normality plots with tests, that's your main one. It's going to give you the Kolmogorov-Smirnov test and the Shapiro-Wilk test. Click, click. Look at the results. So there's all your, that's how many there are. There looks like there's 10 in each group. There's your descriptives, mean, standard deviations. Don't care about that. Here's your test of normality. Okay, so you were asking about the Shapiro-Wilk test. It's right here. And if this sig value is less than 0.05, it violated the assumption of normality, and none of them here did. Okay. Now, if you're going to use the Kolmogorov-Smirnov test, it says empathy number 12 did violate, right, because it's less than 0.05. But since Shapiro-Wilk, I believe, is for the smaller sample sizes, so you can go ahead and use that. So it did not violate the assumption of normality. None of these did. So pressing on, you can look at the histograms if you want, but histograms can be misleading, right? But we already know that they're all normal. Not perfectly normal, but normal enough not to violate the assumption. So there's empathy B. There's a box plot right there. Bam. And there's empathy 3 after 3 months. Doesn't look normal to me, but it's normal enough. That one does not look normal to me at all, but again, it's normal enough according to the Shapiro-Wilk test. And there's empathy 12, same thing. They don't look normal to me. But according to the output, we are going to pretend they are normal, right? So that's all them. Now, next thing we're going to do is we're going to, ooh, there that is. So these are histograms, okay? So I'm going to send you the link on a histogram, and I'll send you a link on what a stem and leaf plot is. Do not use the stem and leaf plot. That is too 1950s. And then you're talking about outliers. So, again, these QQ plots, any point that's away from the line, that tells you if it's far enough away to be an outlier. You can also look at your box plots, but those aren't very good ways to check for outliers. Let me show you the fastest way to check for outliers. We're going to use the Dr. Gebert's method. So let's just go up to Analyze. We're going to go to Descriptive Statistics, Descriptives again. Bam. We're going to stick in all of your repeated measures. We're going to click that little tiny box. Save standardized values as variables. That's all we need to do. Click that. So what it's going to do is it's going to give you a whole new set of variables that are standardized of these guys, and they should be right here. Right here they are, right? Boom. So these are the z-scores. So we're going to go to here, and we're going to put them in descending order. Anything over 2, it's actually 1.96, or under negative 1.96. So in other words, if it's greater than 2 or less than negative 2, you can call it an outlier. Okay? So no outliers here. No outliers here. No outliers here. I don't see any outliers anywhere. Right? Again, there are no numbers here. Oh, here's one. You got one outlier right there. That number is greater than 1.96. But it's just barely an outlier, so I would just leave it alone. But that's the fastest and best way to check for outliers is turn them into z-scores, and if they're greater than 2 or less than negative 2, it is officially an outlier. But again, if it's not that big of an outlier, don't do anything with it because it's not going to really change the output of the data. So I thought I'd pull up a picture of a stem plot. Here's a stem plot. We don't do this. We haven't done this in 50 years. But the first numbers on the left here are the shared first couple of digits for a bunch of numbers. So this means 34084. The second one means 33045, 33565, 33739, etc., etc. You got it? And again, we don't use those. These are in the Hawk one if you're just dying to know. All right, so that should answer most of your questions, right? Shapiro Wilks has to do with your normality of your DVs, which are your repeated measures in this case, and box plots. Box plots, they break your data down into quartiles. Again, you don't need those. They're not a good indicator of what's really an outlier. Use the method I just showed you. Change them into z-scores and check them like that. But now I'm going to just run the test for you real quick. So we're going to go to Analyze, General Linear Model. We're going to go to Repeated Measures. Get in there, you. Bam. And so the first one I'm going to call Empathy, E-M-P-A-T-H-Y. And there are 4 repeated measures, 4 levels. Add, and we're going to define those. And it's Empathy B through Empathy 12. Boop, boop. Got it. And then that's okay. And it ran the first one. So just look at the first one here. So don't look at the multivariate test box. You can, but don't. I mean, it's a little bit, it means more than what you think it means. But here's the 4 repeated measures. Here's your test of sphericity. This is your new assumption for this ANOVA. Repeated measures ANOVA, also called a within groups ANOVA. It has the assumption of sphericity. Now, you use the Mauchly's test. If the significance value is less than 0.05, you violated the assumption. And this one did not. But it's not a big deal if you did violate. So let's just pretend that the empathy was less than 0.05. Then all you would do is pick one of these, what we call corrections here. And Dr. G likes the Hunfeld, so that's the one we use. And we would just use the data from this row, right? If it was significant, you would use the data from the Hunfeld row instead of the sphericity assumed, which means it wasn't violated. And it showed a significant difference between the repeated measures, okay? Just for the empathy, right? Because the sig value is less than 0.05, and it did not violate the assumption. So you would go back up here to the means. Where are the means? There they are. Oh, here they are right here. Sorry, my bad. So, right, empathy B was 8.9, and at the end of 12 months, it doubled, right? It went up to 0.16. So there was a significant increase there. And I'm going to redo the thing for performance. In fact, I'm going to try them both this time. General linear model, univariate. And, oh, this is not a univariate, my bad. Analyze, general linear model, repeated measures. So we already got one. Now we're going to add a second one, and we'll add on performance. Perform. Same thing, 4 levels. And we're going to define it. Let's add it. And then we're going to define the 4 levels as performance, and everything else should be here. That's fine. Actually, we should probably do, what do we want? We want options. Yeah, we should probably get the descriptives, fact size, power. Now, and again, I've never done 2 at once here, so this is going to be a first for me, if we can get it to do it. And I don't think we can do 2 at the same time, right? See, I'm getting a grayed out thing. So I don't know how you run 2 at the same time. So I suggest you do them 1 at a time. Boom. All right, but that's basically it. I hope this helps. And it's good to hear from you. So I'll talk to you later. MGZ out. And that stands for Math Guy Zero. Math Guy Zero. Ciao.